Hi, my name is Eliana Kenner, and I am doing my capstone on proton NMR analysis of aluminum clusters. Aluminum clusters are molecules that can form in slightly acidic conditions that vary in size and shape. A few examples are shown here: the aluminum dimer with just 2 aluminum atoms, the aluminum 8 with 8 aluminum atoms shown in teal, and the Kagan aluminum 13, which contains 13 aluminum atoms. One application for aluminum clusters is antiperspirant. Antiperspirant is composed of aluminum chloride with a little bit of the amino acid called glycine, and sweat is composed of water with a small amount of electrolyte such as bicarbonate, which makes it slightly acidic. When antiperspirant is applied, it dissolves into the water and forms clusters which clog up the sweat ducts to prevent sweat from leaving the body. The three main factors that affect which clusters are present in the solution is the pH of the sample, the specific salt, for instance, aluminum chloride versus aluminum nitrate, and the concentration of aluminum. Typically, clusters are analyzed with aluminum-27 NMR or mass spectrometry. Aluminum-27 NMR is an instrumentation technique that uses radiofrequency spectroscopy to make a spectrum of different peaks at different frequencies corresponding to the different aluminum atoms. This helps to determine the identity of the structure. However, one issue is that it cannot identify highly symmetric molecules. Mass spectrometry is a technique where a sample is aerosolized and then enters a vacuum to break apart into little charged particles. The issue with this is that it can be difficult to tell which broken apart pieces were initially there versus created from the mass spectrometer. For my capstone, I will be using a slightly different technique called proton NMR, which uses NMR but with hydrogens. When you run this for a sample of aluminum clusters, it creates one peak shown here on the left, which corresponds to the hydrogens in water. However, a specific solvent suppression technique called NOSI PR1D can be used to reduce this peak and allow the other peaks to be shown, which correspond to all of the different hydrogens in the sample. In this case, the aluminum 30 with 30 aluminum atoms. I ran my sample the day I created it, 10 days later, 1 month later, and then 2 months later. And as you can see, the peaks are changing over time, which tells us that the composition of the clusters is changing over time. This is just a short bit of information about a rather complex topic, but I hope you found this interesting. Please let me know if you have any additional questions.